Today we're going to talk about digital additive synthesis, which is the process of using software to combine simple sine, cosine waves and also non-sinusoidal signals such as random noise together through superposition techniques, which is adding, manipulation techniques, which is multiplying, and normalizing techniques, which is squishing. And that will create a unique timbre effect, which is a unique sound. I'll show you some of the sounds I've created. That's sine, simple sine wave, high chorus pop, tuba, spooky xylophone, this is kitchen, cool. So you can create these instruments over in Excel, and they feed into this MATLAB program that I've written. You can pull them in through this timbre building workshop panel up here. You can save them, you can load them, you can see the signal time domain, you can see the frequency amplitude spectrum, you can change the volume. So now let's go over to the timbre building workshop and see what's going on. So there's two sections to it. There's the parameter section, which is where you type in the parameters of all the different effects. And then there's the transient envelope call section, which is where you call envelopes to apply to these special effects. And these allow for each effect to change over time. So let's run through each one of these special effects and just talk a little bit about them. I'm not going to go deep into any of them. If you want to learn more, look them up on Wikipedia. The first effect is sampling frequency, which basically controls how many times the sound is sampled per second. Higher number, higher quality, lower number, lower quality, but higher quality means longer time to build and more memory consumption to save and store. Frequency is what is the lowest frequency that the keyboard's going to build at. What is this frequency? It's 300 cycles per second. This can make it a transient, like the Doppler effect, like ooh, you know. Okay, harmonics are all the energy levels of frequencies that can be combined together to maintain periodicity across the more complicated sinusoidal wave. Chord is the ability to add a bunch of different notes together into one chordal timbre package. And each time you spawn a note, all of these notes are going to be called all at once. Noise is the ability to apply random noise to your sound signal. Mod pack low is the ability to apply low frequency and amplitude modulation to your timbre. Mod pack high is the ability to apply high amplitude and frequency modulation to your timbre. And high frequency modulation is the controlling effect for brassy sounds. Cluster pack is the ability to apply chorus effects to your timbre, which causes the note to sound kind of quivery, echoey, spooky. Rand pack is the ability to make these harmonics slightly imperfect, which is important because if you don't do that, it sounds too robotic, too perfect, and everything in life isn't perfect, so that's why that's an important technique. So anything boxed up here is going to be able to call these transient envelopes down here, and both of these parameter sections are going to feed into that MATLAB panel over on the right. One last thing to talk about is what an ADSR envelope is. Basically, number 9 envelope down here is the dedicated ADSR envelope, which stands for attack, decay, sustain and release, and this is important to control the loudness contour of your sound over time. So I'm going to build this sound that I've parametrized in Excel. That's digital additive synthesis. Thank you.